Okay, we're going to get a look at finding the factors of this two-term cubic function, where the first term is something x cubed, and then it's plus or minus, and then a constant. This works when I have, this technique only really works when I have it of this form. So it has to be 2 cubes, plus or minus doesn't matter, it has to be 2 terms. So what we do is find what is the cube root of each term, and I get over here a 2x and over here a 5. And then the technique is to take that 2x and that 5 and same sign as the original, a plus. Then I take my first thing I got and square that. So 2 squared is 4, x squared is x squared. Then opposite side, product of the two numbers, 10x, and then this always positive, and then the second thing I found squared. So it's cube root, those two answers, same sign. This squared, the product, and then this squared, and then the signs are same, opposite, always positive. Okay, so I factor that. Finding the inverse, just a reminder on the steps on finding the inverse, you switch x and y, and then solve for y. Switch x and y, and solve for y. So here we go, I switched x and y, moving my 125 over. Same process we did for linear functions. Now there's a cubed thing, but it's no different. I'm still solving for my singular variable. I'm going to leave it as this fraction. You could write x over 8 minus 125 over 8, but I'm going to leave it like this. And I have y cubed. To simplify, to get the y isolated, I cube root both sides. And I have x minus 125 all over 8 is y. And we always write our answer with that format. The inverse is the original function was g. The little -1 of x equals cube root of x minus 125 over 8. This would be my answer. As I said, you also could write it where the 8 is over each piece individually, but either way, you can't simplify in a radical. You have to leave it like this. You cannot pull out the 125 over 8 because of the minus sign. So these are my two answers. You could write it either way. Both are correct. Doesn't matter which one you write it. Okay, and then just reminding us for the prove, you have to take the inverse, plug it in for the x's of the original, and then vice versa. Plug the original into the x's of the inverse. So just to show you one example, here's my original 8x cubed plus 125. I'm going to take this one, my inverse, cube root of x minus 125 over 8. Cubing a cube root makes that go away. So I have 8 times x minus 125 over 8. My 8's cancel. So now I get x minus 125 plus 125. And I get x. So I proved it one way. Time to prove it the other way. My inverse, cube root of x minus 125 over 8. Okay, and now I plug in, oh, I'm sorry, this should not be there. There's my inverse function, x minus 125 over 8, and then I plug in the original, which was 8x cubed plus 125. These two 125s will cancel out. I have 1 plus 1 minus. So now I have the cube root of 8x cubed over 8. those cancel out, so I get the cube root of x to the third, and I get another x. So I approved it now both ways. This is relatively simple because it's just a singular x to plug into, and then my cubes cancel out my cube roots, or in this case, my constants cancel out, and then the 8s, and then the cube, and then now the 8s, and then the 125. So it's really the same thing both ways. Okay, so factoring, here we go. I have factored it completely. This is done. And then I have found the inverse, and then I have proven it in both ways I need.